Welcome to Ask and Learn.
To solve this question, we need to find the capacitance of the capacitor, which is somewhat like this. This has thickness of L. So capacitance here, this one and this one, they are same. There are two capacitors in series. So the capacitance here is given by twice A epsilon naught divided by D minus L. Since this distance is D minus L divided by 2. Same is the case with this. So the net capacitance of these two capacitors is Cn equals 1 over C plus 1 over C. And if you solve it, you get Cn equals A epsilon naught divided by D minus L. Let's also calculate the charge stored on the capacitor when it is connected to the battery. Q equals CV naught, or just CV is enough. So that will be A epsilon naught V divided by D minus L. Now, to solve the first part, which says find the change in energy when the plate is removed while the battery is connected. That means the potential is the same. So in this case, you can simply use dW is equal to half. Since when you remove the plate, you're changing the capacitance. So dC V square. So let's find dC. dC is initial capacitance minus the final capacitance. From this is your initial capacitance. Initial capacitance now is A epsilon naught divided by D minus L. Final capacitance is A epsilon naught divided by D, since you remove the plate. Now this gives you A epsilon naught L divided by L D minus L. Oh, I'm sorry, this should be D. Now just substitute that to find the work done. So the work done in this case is equal to V square divided by 2 A epsilon naught L divided by L, sorry again, D minus L. Now in the second part, we are supposed to consider that battery is disconnected. That means the charge is constant. That's where we are going to use this quantity over here. So to find that, let's use different approach. When you have the battery connected and the plate inside, the energy in that case is half C V square. Since we are going to disconnect the battery in the end, let's denote it by V naught now. So in this case, this is initial energy. Initial energy now is equal to half. Since we know initial capacitance is A epsilon naught divided by D minus L, and simply V naught square. Final energy in this case is half final capacitance Since we can also use another formula for the energy, let's use that one, q square by c, because we have information about q square. So in that case, your q square is substituted as a epsilon naught v naught squared divided by d minus l squared, and 1 divided by c. Now in this case c is the final one, so that is on this one. This is your c final, so you're going to use this now. A epsilon naught since it's inverse, it should be d divided by a epsilon naught. Now all you have to do is cancel a and epsilon naught here, so we have only a epsilon naught remaining in the numerator, and subtract to find delta U, which is equal to dW, that is the work done. The change in energy is also conceived as a work done. Now if you subtract these two quantities, you get half. I'm taking all the factors common, so you can work out this middle step by yourself. So answer in this case is simply half a epsilon naught v naught square divided by d minus l square times l with the negative sign.